The California almond growers have at most 2,400 boxes of almonds to be shipped from their plant in Sacramento to Des Moines and San Antonio. The Des Moines market needs at least 1,000 boxes, while the San Antonio market must have at least 800 boxes. We're being told to let X be the total number of boxes shipped to Des Moines, Y be the number of boxes shipped to San Antonio, and we want to graph the system of inequalities that results from these constraints. It doesn't say that right here, but that's what we're doing. So let's think about what kind of restraints there are, what kind of constraints there are, rather. So X is the number of boxes shipped to Des Moines. Let's see what kind of restrictions there are in the number of boxes shipped to Des Moines. Well, I know that there must be at least 1,000 boxes shipped to Des Moines. So we get X is greater than or equal to 1,000. Technically, we would also want to say the number of boxes shipped to Des Moines should be non-negative. Kind of like we saw in that last problem. In general, when we have these variables, we should say that they're non-negative. But this is actually redundant in this case. If X is bigger than 1,000, we already know that X is bigger than or equal to 0. So we can kind of get by without doing that one. For boxes shipped to San Antonio, the San Antonio market must have at least 800 boxes. So we're going to say Y is greater than or equal to 800. And similarly, we would normally do Y is greater than or equal to 0, but that one's unnecessary if we're already saying Y is bigger than or equal to 800. All right. The only other constraint I see here is that there is a max number of boxes that could be shipped in total. There's a total. This other constraint is referring to the total number of boxes that are shipped, and the total number of boxes that are shipped, well, we're only shipping them to Sacramento and Des Moines, so X plus Y, or sorry, not to Sacramento, to San Antonio and Des Moines. So X plus Y is the total number of boxes shipped, and we need this to be no more than 2,400, so we want it to be less than or equal to 2,400. It looks like those are all the constraints that I have here. Let's see. Let's think about what these lines are. I'm getting ready to graph these. This is a vertical line. Actually, let me just say vert. This one is a horizontal line with all the y coordinates of 800. And this one, if the x coordinate is 0, we get y equals 2,400. So that's 0, 2,400 for that intercept, and similarly 2,400, comma 0 for the other intercept. So whatever I'm graphing here, or whatever scale I choose, I want to make sure that these values show up in there somewhere. So I already know that there's 10 spaces here, so let's say this goes up to, I could do 3,000, I suppose. Yeah, let's go up to 3,000, which means each of these is a step size of 300. This would go up to 3,000. Okay, so we want, first off, I'll graph this line, x equals 1,000. That's a vertical line. This would be 300, 600, 900. If we're talking about 1,000, we're going to be just a little bit further. Not quite that far. Let's try there. This I'll call my first line, this one here. And we need to be to the right of this line because the origin does not satisfy this one. If we ship zero boxes to, where is this, Des Moines, they would not be happy because it says we need to ship at least 1,000 boxes. So we need to be shading to the right here. We don't want to shade toward the origin on this one. For here, we want y to be greater than or equal to 800. This is a horizontal line. 900 is there, 800 is just below it, so we're going to look something like this. This will be line 2. And we'll want to be shading for, similar to the last one, we want to shade above this line because we want the total number of boxes shipped there to be greater than or equal to 800. The origin would not satisfy that, so we'll shade on the other side of that line. And then lastly, we want this, this line, 0, 2,400, and 2,400, 0. Let's see, 2,400 is there, and 2,400 is here. So when I draw the line that connects those, it looks kind of like that. Let's test the origin here. Well, if I send 0 boxes to both of them, I don't oversend. You know, the total number of boxes is not violated. So I would want to shade toward the origin here. You can see when I'm talking about this particular constraint, I don't really care about the other two when I'm figuring out which way I shade. 0, 0 satisfies this constraint, so I would want 0, 0 to be in the shaded region for this line. So that's why you can see I gave the little arrow pointed toward the origin. It's on the same, toward that half plane. So taking these into account, I need to be to the right of this, above this, and below that line. That's this region right here. So there is my graph of the system of inequalities here.